let's talk for a moment about some of the modern encryption standards that we can use with 802.11 to make it more secure. First off, let's talk about temporal key integrity protocol, TKIP. Okay, everybody you talk to will reference it as TKIP. Now, this is pre-WPA2. So WPA2, which we'll talk about a little bit later, is the most modern. So this is a little older, right? 802 TKIP was introduced to fix WEP. That's what it was. When WEP was released, it was almost immediately broken. So everybody had to come up with a way to get this wired equivalency. We wanted privacy on our wireless networks. They decided to use the encryption TKIP in association with WEP. So we're still using that we're still using RC4. We're still using WEP as the backbone to carry it, but we're using TKIP to make it more secure. So this is based on the 802.11i security recommendation. This is software only. We didn't need to change any of the hardware involved. You didn't have to swap out your wireless cards or anything to get this working. It was a software only implementation. And again, we were running on the back of that RC4 encryption, which was the backbone of WEP to get things encrypted. So you remember that wired equivalency protocol that just didn't work. So we applied it here to WEP in an attempt to make it more secure. And although it did make it a tiny bit more secure, we still had several of the drawbacks of WEP, and we just had to drop it and move on. And what did we move on to? We moved on to WPA, Wi-Fi Protected Access. This was much more secure. And this was introduced in 2003. And again, TKIP was applied to WPA. Now, WPA used pre-shared keys or other enterprise authentication in order to get this to work. And initially, it had a 48-bit initialization vector. So that's 2 to the power of 48 was our encryption standard, 2 to the power of 48. Wow, that's the number of values we could have. That's a lot. And we use this with TKIP. Much more protected access than WEP ever was. And we still see this in some environments used today. Now, WPA uses a mix of different values in order to create that security. It uses the master key, the packet number, and the MAC in a two-phase process to create its encryption. So there's a lot of information going there, and we can encrypt in a 2 to the power of 48 value. That's a tremendous amount of encryption that can be done. And this value, all these put together in that two-phase process creates our packet key. Now remember, this is going to change. The packet key is not static in this case. We're going to be moving because one of the values is our packet number, isn't it? So this is much harder to hit because it's a moving target. WEP was static. It never changed. Mathematically, we have a change now. There's a delta introduced. So this makes it harder to break. Now, is it completely unbreakable? No, given modern computing powers, this isn't exactly the hardest thing to break ever. So we've moved on from this even. We've moved on to AES. Okay, so AES became the new encryption standard, right? Now we're going to implement this with WPA, and we're going to implement this with WPA2. What did this do? I'm going to put another bullet point. It killed TKIP. Temporal key integrity protocol was replaced. We no longer needed it. Not good enough. We now relied on advanced encryption standards. And the key size are 128, 192, and 256 bit. That's 2 to the power of those numbers, folks. That's how many values we're working with, our key sizes. Those are huge numbers. That's like an undecillion. 2 to the power of 128, I believe, is an undecillion. So large numbers we're dealing with. We had to change up our hardware a little bit. We couldn't use the same old hardware. This is the first time we weren't backwards compatible. We had to move to newer hardware in order to implement this. This can be used for WPA and WPA2. We can backwards use it, but why? If you have access to WPA2, more secure, why not use it? Now, this was WPA2 was introduced in 2003. Remember, WPA1 was released in 2003. Almost immediately had problems with it, even with TKIP involved. That's why we started adding different things, trying to make it work. Didn't work. We went right to WPA2. We use pre-shared keys or enterprise authentication, radius servers, things like that can be put in play. Uses AES for encryption. We're no longer relying on TKIP. Didn't make it. And in today's modern world, this is the most widely used. Most widely used in our environments. This is what everybody's using. Nothing new is on the horizon. This is what everybody's using. Look at the date here. Long in the tooth, isn't it? Because we have this AES encryption standard that's keeping it alive. Right? So still valuable in today's environment. One of the reasons this is still valuable in today's modern environment, I don't see it here. I'm going to add it here. From WPA and WEP and all those things, we learned something from all that. Remember, I told you those management frames were static. Those management frames for WEP were an issue. Guess what? We secured the management frames here. Now, I know secured is relative, right? Secured against what? Well, compared to the other protocols before it, WPA was able to secure management frames better than WEP, better than WPA1. So now WPA2 has been able to provide a secure wireless infrastructure for quite some time now. Now, that being said, it's only as good as the encryption you put in place or the passwords you put in place, but it is fairly secure when using large passwords and things of that nature. Harder to crack than WEP, WAP, with TKIP protocols. Very much an enterprise solution.